Damstad, Germany, March 2026. Inside a quiet research facility, a scientist sits at her workstation, finally ready for a moment she has been waiting 4 months for. The data transfer is complete. 5 instruments, 1 target, 12 images, and terabytes of spectral readings from the most advanced deep space probe ever built are now at her fingertips. She opens the first file, reads it once, then again, her mind racing. Then, in a move that surprises everyone, she picks up the phone. Not an email, not the standard reporting chain. She calls her department director directly at 6 in the morning. Her words are simple but urgent. We need to schedule a meeting before anyone publishes anything. That meeting, set for late March, is weeks away. Yet as of March 8, 2026, the data sits in a secure facility, untouched by the public, unannounced, and completely unshared with the 7 billion people who have every right to know what these instruments recorded. Across a multinational research team spanning 17 countries, not one scientist has spoken. No preprint, no forum post, no whispered comment to journalists, just silence. In over 6 decades of deep space exploration, no ordinary discovery has ever been met with this level of coordinated quiet. Now we are in the window. The papers are coming. Statements are being carefully drafted. Words are being chosen. Before the polished version of these 5 instruments' recordings reaches the public, we can examine what has been deliberately left unsaid. This is the data they are holding, the pattern they have not explained, and the reason why a closed-door meeting in late March 2026 may be the most consequential scientific event happening anywhere on Earth right now. To understand the magnitude of the November 6, 2025 observation session and why the data sits locked, we must first understand JUICE, the Jupiter Icy Moons Explorer, and its mission. JUICE is the European Space Agency's flagship deep space science mission, approved in 2012 under ESA's Cosmic Vision program. Its purpose: the detailed study of Jupiter's 3 ocean-bearing moons Ganymede, Callisto, and Europa worlds that theoretical models identify as the most promising candidates for extraterrestrial subsurface liquid water in our solar system. Ganymede alone, the largest moon in the solar system, bigger than Mercury, harbors a confirmed saltwater ocean beneath 150 kilometers of ice containing more liquid water than all of Earth's oceans combined. Launched in April 2023, JUICE carries 11 scientific instruments designed with precision for this mission. Its cost exceeds €1 billion, and each instrument was carefully calibrated to study specific targets, not general observations. The major spectrometer was tuned to identify icy moon compositions. The SWI sub-millimeter instrument was configured to detect specific molecular species in Jupiter's atmosphere. The PEP particle environment package mapped charged particle dynamics in Jupiter's intense radiation belts. These instruments were not built to study comets. Pointing them at an unplanned object requires consensus, approval, coordination, and a scientific justification powerful enough to override the primary mission timeline. Yet on November 6, 2025, 7 days after 3 interstellar objects known as 3I, Atlas, made their closest approach to the Sun, JUICE redirected 5 instruments simultaneously toward this unexpected target. Not 1, not 2, but 5, all working in perfect coordination. In a single observation session, they captured 12 wide-angle images, alongside spectral, molecular, particle environment, and ultraviolet data. At that time, JUICE was 66 million miles away from the objects, on the far side of the Sun. Communications were slow. Few in the world were paying attention. In retrospect, that timing seems intentional, a window when the rest of the world would not notice. The justification for pointing 5 instruments at these objects has not been publicly stated, not in March 2026, not in the months leading up to it. And that omission is not a footnote, it is the story itself. To understand why, we need to examine what these instruments were designed to measure, and why pointing them at an interstellar object was so extraordinary. MAGIS, the Moon's and Jupiter Imaging Spectrometer, operates across visible and near-infrared wavelengths, from 0.4 to 5.7 micrometers, a range ideal for detecting icy and rocky surfaces. Water ice, carbon dioxide ice, methane clathrates, ammonia hydrates, and complex organics each absorb specific wavelengths, creating a chemical fingerprint. For years, the MAGIS team calibrated it against Jupiter's moons. The question it asks is simple and binary. Does this object match known interstellar comet compositions, or is it something entirely different? When MAGIS was trained on 3I, Atlas in November 2025, weeks after the objects had demonstrated electromagnetic countermeasures, trajectory corrections aligned to Jupiter's magnetic field, and post-perihelion activity violating thermodynamic expectations, it was conducting forensic chemical analysis, not casual observation. It was asking the most precise question available: what is this object made of? SWI, the sub-millimeter wave instrument, identifies individual molecular species with exceptional specificity: water vapor, carbon monoxide, methanol, formaldehyde, hydrogen cyanide, even complex prebiotic organics. It functions as a molecular identity scanner, searching not for expected chemistry, but for unexpected signatures, the ones that cause teams to triple-check their results before submission. PEP, the particle environment package, measures fluxes of electrons, protons, and heavier ions across a wide energy range. In Jupiter's system, it maps radiation belts. Pointing it at 3I, Atlas measures how the object interacts with its surrounding electromagnetic environment, something only run when previous observations suggest behavior inconsistent with an electrically inert body. By March 8, 2026, the preliminary data from JUIC's November 6 observation session had been in the hands of the research teams for nearly 2 weeks. 4 months of waiting, and still, not a single public word had been spoken. No press release, no forum post, not even an informal remark to space journalists who follow ESA closely. The silence itself is extraordinary, a carefully maintained quiet that stretches across 17 countries, dozens of institutions, and hundreds of scientists. In the history of modern space science, such coordinated restraint is almost unprecedented. Ordinary discoveries leak. Extraordinary yet explainable results generate excitement. But here, the extraordinary data produced complete silence. That alone is a signal. This observation session did not happen in isolation. It was a response to a sequence of anomalies that began as soon as 3I, Atlas, reached perihelion on October 29, 2025. Among the most striking of these anomalies was the data captured by NASA's Spherex telescope in the days following the object's closest approach to the Sun. Spherex, launched in March 2025 as a next-generation all-sky infrared survey instrument, observed the outbound trajectory of 3I, Atlas, after perihelion, during the phase when solar flux electromagnetic energy received from the Sun was decreasing. According to established thermodynamic laws, a comet's activity is directly tied to solar flux. As a comet approaches the Sun, heating triggers sublimation. Volatile ices convert directly from solid to gas. This drives the comet's brightness, the expansion of its coma, the formation of its tail. As the comet recedes, the reverse occurs. Outgassing decreases. The coma contracts, brightness fades. This is not a tendency or statistical average, it is a universal law confirmed across centuries of observation. But Spherex recorded something impossible. As 3I, Atlas moved away from the Sun, losing energy from decreasing solar flux, it flared. Its brightness and activity increased, in direct violation of the inverse square law that governs solar energy. Every natural mechanism for post-perihelion brightening requires specific coincidental circumstances. Subsurface volatile patches in precise locations releasing material at just the right moment. Yet the flare observed was not random. Its timing, intensity, and scale suggested a deliberate, scheduled increase in output behavior consistent with an engineered system transitioning from survey mode to departure mode, activating systems held dormant during its observational pass through the inner solar system. This interpretation, while theoretical, gains weight when combined with earlier anomalies. JUIC's 5-instrument redirection on November 6 was not casual curiosity. It was a coordinated effort to perform forensic-level measurements. MAGIS recorded the near-infrared spectrum. SWI measured molecular signatures at sub-millimeter frequencies. PEP mapped charged particle interactions. Each instrument targeted a different facet of the object's chemical, structural, and electromagnetic profile. The preliminary data suggested behavior inconsistent with a passive, natural body. Even more striking, other observational anomalies had been recorded earlier, briefly discussed in scientific circles, and then quietly dropped. Cryovolcanism, for instance, the eruptive release of volatiles from a body's interior, powered by internal heat rather than solar energy, was detected on 3I, Atlas. Multiple independent observatories reported signatures resembling sustained internal energy release, akin to phenomena observed on Enceladus and Europa. In normal scientific practice, such claims would either be confirmed or formally retracted. Here, they simply vanished from discussion. That absence is itself a data point, hinting that natural explanations were insufficient to provide certainty. Adding to the mystery, X-ray instruments detected an enormous halo extending roughly 250,000 kilometers from 3I, Atlas's nucleus, almost two-thirds the distance to the Moon, in every direction simultaneously. While X-ray emission in comets can occur through solar wind charge exchange, the sheer scale and intensity profile of this halo defy conventional expectations. The anomaly is still under study as of March 2026, unresolved, unreported, and unexplained publicly. The emerging pattern is startling. Stabilization jets precisely aligned, an electromagnetic countermeasure operating at 1,665 MHz. A trajectory correction matching Jupiter's magnetic axis, a 1.42 GHz signal with a 99.7% probability of artificial origin. A directed beam toward Earth. Cryovolcanic activity unresolved, an X-ray halo of unprecedented scale, post-perihelion brightening defying thermodynamic law. And then, the coordinated observation by JUIC's 5 instruments. Taken individually, each anomaly could have a natural explanation. Taken together, as a sequential pattern, they describe something entirely different, something active, structured, and operational. Institutional context amplifies the significance. When the LIGO collaboration first detected gravitational waves, data release followed within months, accompanied by press conferences and open publication. The Event Horizon Telescope's black hole image was announced with full transparency and simultaneous global coverage. Even routine discoveries, like water ice on the Moon, were communicated openly. By contrast, the JUIC data has been intentionally withheld, framed only for discussion in a closed late March meeting. That kind of silence across an entire multinational network is not routine, it is a deliberate signal. This carefully orchestrated quiet, combined with the extraordinary observational anomalies, suggests that the data is not just unusual, it is potentially transformative. Every decision, from the timing of JUIC's observations to the delay in data release, points to the recognition that what is contained in that folder could redefine our understanding of interstellar objects. This is why the scientific community is holding its breath. The anomalies of 3I, Atlas, are not restricted to brightness or electromagnetic behavior. Its interactions with its environment, measured by PEP, indicate a body that is not electrically inert. Subsurface processes, evidenced by potential cryovolcanic activity, suggest sustained internal energy output. X-ray emissions cover extraordinary distances, and radio emissions show structured, potentially artificial patterns. The sequence of anomalies is cohesive, not random, a profile consistent with a system executing a precise operational program, not a rock drifting through space. And yet, all of this remains unannounced, unpublished, and unshared. The wait continues. A closed meeting is scheduled for late March 2026, and the world has no idea what lies within those terabytes of data. But the silence itself, 4 months of careful restraint across 17 countries, hundreds of scientists, and multiple observatories, is perhaps the first true signal this interstellar visitor has sent us. As the late March meeting approaches, the world remains unaware of what is about to be revealed. Behind closed doors, a small circle of scientists will examine the data in unprecedented detail, weighing interpretations, confirming anomalies, and deciding how to present findings that could challenge long-held assumptions about interstellar objects. This is not a routine discussion. This is a moment that could reshape planetary science, astrobiology, and our understanding of advanced physics in a single observation campaign. The anomalies observed in 3I, Atlas, are not isolated quirks. Each piece of data connects to the next, forming a coherent operational profile. Geometrically precise stabilization jets indicate control. Electromagnetic countermeasures at 1,665 MHz show active interference with spectroscopic measurement. Trajectory corrections aligned perfectly with Jupiter's magnetic axis demonstrate deliberate navigation. A 1.42 GHz signal aimed at Earth has been identified with near certainty as artificial in origin. Cryovolcanic activity, still unresolved, suggests a sustained internal energy source. X-ray emissions extend hundreds of thousands of kilometers in a symmetrical halo. Post-perihelion flares defy thermodynamic laws. And, of course, JUIC's 5 instruments captured coordinated observations of all of this, simultaneously producing terabytes of high-resolution data. Viewed individually, each anomaly might be explained naturally, with some effort. But seen together as a sequence, these anomalies do not describe a comet or asteroid. They describe a system structured, responsive, and operational. In other words, this is an object that behaves with intent. It reacts to its environment. It emits energy and radiation in patterns that suggest intelligence or, at the very least, precise engineering. The universe rarely announces its most significant discoveries with fanfare. Instead, it leaves patterns for those capable of reading them. The silence surrounding this data, maintained over 4 months by hundreds of scientists across 17 countries, is its own signal and acknowledgement of its importance. The implications of this are profound. If 3I, Atlas, is an engineered object, perhaps a probe or artifact from an advanced civilization, it represents the first direct evidence of extraterrestrial technology entering our solar system. Every observation from stabilization jets to artificial radio signals could redefine how humanity understands both natural and artificial interstellar phenomena. Even the unresolved cryovolcanic activity and X-ray halo take on new meaning in this context, potentially signaling power systems and environmental control mechanisms far beyond anything found naturally. Yet, the scientific community is cautious. Extraordinary claims require extraordinary evidence, and the ESA teams are meticulously analyzing every byte of data. They must ensure that no miscalculation, no instrument anomaly, no natural explanation has been overlooked. The closed meeting in late March is part of this process, a controlled environment where experts can align their interpretations and decide on the most accurate, defensible narrative to share with the world. This is not secrecy for secrecy's sake. This is scientific rigor, elevated to its highest standard, applied to data that challenges the very foundation of cometary physics, planetary science, and our understanding of interstellar phenomena. History offers a benchmark. When gravitational waves were first detected, the announcement followed months of rigorous review, but transparency was immediate once verified. The Event Horizon Telescope shared its black hole image with the global community simultaneously. Even the discovery of water ice on the Moon moved swiftly from observation to publication. In contrast, JUIC's November 6 observation has been withheld intentionally. The deliberate delay, combined with the coordinated silence, highlights that this is no ordinary finding. The pattern of anomalies, coupled with the institutional response, indicates that the stakes are unusually high. Consider the timing. Every decision from redirecting 5 precision instruments simultaneously to choosing the far side of the Sun observation window points to calculated intent. The scientists are not scrambling to analyze minor irregularities. They are investigating a carefully orchestrated, multi-layered phenomenon that may have been billions of years in the making. The post-perihelion flare observed by Spherex alone violates centuries of cometary thermodynamics. The X-ray halo scale challenges every known model of particle interaction in small bodies. The electromagnetic signatures suggest active interference or communication. Each of these anomalies, remarkable on its own, forms a coherent operational profile when combined. This brings us back to the upcoming meeting. For the world, it will be the first public acknowledgement of what JUIC recorded. For the scientific community, it is a test of how to responsibly communicate findings that could alter our understanding of interstellar objects, planetary geology, and possibly extraterrestrial technology. The stakes are enormous, but so too is the opportunity. In the coming weeks, papers will be drafted, statements prepared, and the world will finally see what has been hidden in plain sight for months. Until that moment, the silence speaks volumes. It communicates the extraordinary nature of the data without a single word. It signals that what is contained within those terabytes of spectral readings, molecular signatures, particle interactions, and electromagnetic measurements is not ordinary. It is unprecedented, coherent, and perhaps, for the first time in human history, offers a glimpse into a technology that is not of Earth. And for viewers watching this, the implications are personal as well as scientific. This is a reminder that the universe holds surprises beyond imagination, that careful observation, patience, and meticulous scientific discipline are our tools for understanding the cosmos, and that sometimes, the most important discoveries arrive not with fanfare, but in the silence maintained by those who understand their weight. In the coming weeks, when the results of the late March meeting are finally shared, the world will be invited to confront a pattern that has remained hidden, to see the anomalies that were deliberately withheld, and to engage with the evidence that challenges conventional explanations. Until then, we watch, we analyze, and we prepare to absorb what could be one of the most significant revelations of our time. If this fascinates you, if the mysteries of 3I, Atlas, and the unprecedented data from JUICE capture your imagination, make sure you stay updated. Subscribe, hit the notification bell, and join the conversation as humanity prepares to confront one of the most extraordinary scientific events in history. The story is just beginning, and you won't want to miss a single development.